Good evening, students. I am Dr. Bindra. Today we are going to study the photoelectric effect. So let us start. Okay, let us start with the photoelectric effect. The photoelectric effect is about the ejection of electrons from the metallic surface. As you already aware about photoelectric effect, you might have done this discussion at the high school level. What exactly it is? It is basically that suppose we are having the metallic plate, and when the photons are basically incident on the metallic plate, there will be ejection of electrons. Okay, this ejection of electrons that is basically coming inside the you can say metallic surface. Metallic surface we can choose as a sodium, right? That is the photoelectric surface. So, but what are the factors on which the ejection of electron depends? The ejection of electron is basically mainly dependent upon 2-3 factors. The main core factor for the ejection of electron is the frequency. Okay, so frequency, we need to understand what is the role of the frequency in the ejection of electrons. Then we learn about the role of the intensity in the ejection of electrons, and finally we learn about the stopping potential. Okay, so these are the key points which students may note down, which we are going to discuss today. Okay, students, let us learn the photoelectric effect with the help of the simulation. This is the simulation provided by the University of Colorado. That's a fact, right? Let us understand that what is happening inside the simulation. Here the students are able to see that the red color light is striking the metallic surface. We have chosen the metallic surface as sodium. Okay, and what you are able to see that when the light photons are basically striking on the metallic surface, no ejection of electron takes place. Okay, let us change the frequency gradually, and let us take the frequency to 600 nanometer. You are about to see that the color has been changed, and now this time we are getting the color which is yellow, right? And in this yellow color still we are not getting the frequency, because this frequency is also not suitable for providing the photoelectric effect. For providing the photoelectric effect, we should give the suitable frequency, which is called the threshold frequency. Let us move down the frequency to further 500 nanometer. And here you are able to see when we are taking the frequency to the green color, some sort of electrons start coming out. Okay, so this is clear indication that this green color frequency is the threshold frequency. Okay, and when the threshold frequency is being given to the this metallic surface, the electrons are being released. Okay, if we further drop down the frequency to 400 nanometer, you are about to see now we are entering into the UV region. In the UV region, the photoelectrons are emitted in a more number. Their speed has also been increased. Okay, so with the frequency, first they was just emitted. Now they are not just emitted, they are also gaining the kinetic energy. Okay, so here you are able to see that how faster the electrons are being moving. Okay, so this is how the frequency affect the that photoelectric effect, how the frequency basically control the photoelectric emission. Okay, so let us understand further with the help of a graph. Okay, now we come back to the graph. So this was our first question: how does the frequency of the incident radiation affect the photoelectric effect? As you have already seen in the simulation that we was gradually changing the frequency from red to yellow, yellow to green, and finally at green we are able to see that there is a threshold frequency. Green was act as a threshold frequency, right? And here you are able to see this is the threshold frequency point, right? So on the green color we have seen that some sort of electrons has been started. Okay, so if you plot the photoelectric effect with energy as well as the frequency, you are about to see that at the first number, what is the threshold frequency? That was the 500 nanometer. If you remember, that was green in color, and we are able to observe the photoelectric effect. Okay, now we are going to understand our second question, that how the intensity of the light that is affecting the photoelectric effect, that means that is affecting how means intensity is there and how it is changing the photoelectric current. Okay, so here you are able to see initially we have taken the intensity as 20%. Electrons are being ejected. Okay, but the volume of the electrons is less number of electrons are there. Okay, if we increase the frequency to 50%, let it be, right? Now you are able to see the electron number is being increased. Okay, and finally if you take it to the 100%, you are about to see that electron number has been thoroughly increased, and as the photoelectric current is also being affected. Okay, so you are able to see that electron number is continuously increasing. So photoelectric effect is directly proportional to the intensity. More the intensity, more will be the photoelectrons. Okay, but the key factor was the frequency. Threshold frequency is the minimum requirement, but once we achieve the threshold frequency, second key factor is the intensity. More the frequency, more will be the photoelectrons that you can see in this presentation. So let us see with the help of the graph. Here, this is our second question, that how the intensity of the incident radiation affect the photoelectric effect. So when we talk about the intensity, here is the photoelectric current, here is the intensity. As the intensity is increasing, photoelectric current is also increasing. So they are basically directly proportional. Okay, more will be the intensity, more will be the photoelectric current. Finally, there is a third thing which you need to learn about the photoelectric effect, that is the stopping voltage. Okay, so here the students are able to see that the voltage we have given to the photoelectric effect as 2 volt. Okay, and the current correspondingly we are getting 0.141, right? Now here the students are able to see that the photoelectric effect is happening. Okay, the photons are being striking on the metallic surface, sodium, and the electrons are being released, right, in simpler way. Now if we start dropping the stopping voltage, and let it be the stopping voltage is being dropped to 0. Okay, earlier it is 2 volt, now we have dropped to 0 volt. Okay, so there is a little effect on the photoelectric current, and you are able to see that as we are dropping the stopping voltage, the photoelectron speed start dropping. Okay, now if we further drop the stopping voltage in the negative side, means -2 volt. So here the students will see the special effect on -2 volt. Here you are able to see the first thing, the photoelectric current becomes 0. You are able to watch the photoelectric current become 0, and at the same time the released photoelectrons, they are not participating into the photoelectric current. Okay, what we are able to see here, the photoelectrons are being released, but they are losing their energy in terms of heat, and we are not getting any output of the photoelectric effect. Okay, at the point where we get the 0 photoelectric current, that is around -2 volt. Okay, so this voltage, this particular voltage, what we call it as a stopping voltage. Okay, so 3 key factors we have learned in this discussion: frequency, intensity, and finally what we have, the stopping voltage. Electrons are there, they are ejecting, but they are not participating into the photoelectric current. This point, which we specifically call the stopping voltage, and here the photoelectric current becomes 0. Okay, the final point, that how the stopping voltage that basically affects the photoelectric effect, we have already seen through the help of a simulation. Now finally let us discuss on the graph also. Here the students are able to see that as you already know the role of the threshold frequency. Threshold frequency was started with the green color, but if we choose the UV light, the threshold frequency is being changed, and accordingly the stopping voltage will also be affected. Okay, suppose this is the threshold frequency for the green color, so stopping voltage is different. For the blue color, the stopping voltage is different. Okay, so this is the graph between the photoelectric effect and the potential, right? So the photoelectric effect that is giving the negative potential, means if you are having the different frequency, different stopping voltages are being noticed. Okay, so this is the stopping voltage for the green color, this is the stopping voltage for the next UV light. If you go beyond that frequency, you are going to see that the behavior of the stopping voltage is being changed. Okay, so this is the final slide. I hope you understand the photoelectric effect in a thorough manner. For further videos, you can subscribe my channel, and as well as you can hit the bell icon, so that I can post more and more videos on your for your help.